Hi there. Today, we're walking you through our hybrid anime recommendation system. Recommending anime sounds easy until you actually try it. People binge watch whole shows, genres overlap like puzzle pieces that don't fit, so a basic similarity check falls apart fast. Our fix was to build a hybrid model. Instead of relying on one method that misses half the picture, we combined multiple approaches so they support each other. Our system works through three main parts: content-based filtering, item-based collaborative filtering, and a deep neural network. This uses the anime's actual features, genres, themes, the summary, all that descriptive info. It checks what the user liked before and finds similar items based on those features. This uses behavior. It looks at ratings from people with similar tastes and suggests shows they enjoyed. It's how we pick up on unexpected recommendations you wouldn't find through just genre matching. This is the smart mixer. It takes the signals and embeddings from both previous models and learns deeper patterns. Basically, it figures out relationships humans don't consciously notice. Our entire system relies on the dataset in dataset.txt, a file that contains a Kaggle link to the database we're working with. We have titles, genres, and a huge set of user ratings that powers the collaborative filtering and deep neural network parts. We cleaned the data first, removed entries marked as unknown, fixed inconsistent names, and made sure everything links up correctly. For the text features, we use TF-IDF, which stands for Term Frequency Enriched Document Frequency. In simple terms, it turns text into numbers based on how important each word is. Common words like the get ignored, and rare but meaningful words like mecha or psychological get higher weight. This helps the content based model compare anime in a logical way instead of treating all words the same.
Hi, I'm Aisha Javed. I wanted to build a tool that recommends anime based on shows I already like. So here's the script I wrote to build a content-based recommendation system. I have imported pandas for data manipulation and scikit-learn for machine learning components. Two type of datasets, anime.csv and ratingcomplete.csv. Then I have converted the English names to lowercase for better search function. And now, this block is the core of the recommendation system logic. Since this is the content base, I need to create a single signature for each show. I created a column called combine features where I am literally combining the general duration and favorites count into one long string of text. This gives the algorithm a lot of keyword to compare with. Then there is a problem that computer does not understand text, so I have used tf idf factorizer from scikit-learn to combine features text we just made and converts it into a matrix of numbers. It basically figures out which word are the most important for identifying that specific anime. Once the data is vectorized, I calculate the cosine similarity here. Think of this as creating a massive grid. It compares every single anime against every other anime to see how mathematically similar they are. If the angle between them is small, they are a good match. Finally, I wrapped everything in this function get recommendation.
For our file item-based collaborative filtering, we're building its foundation. We're using a technique called matrix factorization. The goal is to take that massive sparse rating history and break it down into two smaller, powerful pieces. These smaller matrices contain what we call embeddings or latent features. They are the hidden characteristics, the reasons why a user likes an anime represented as numbers. By multiplying a user's embedding by an item's embedding, we can predict the exact rating the user would give to any unrated anime. But we don't stop there. Traditional CF is great, but it's largely a linear prediction. To capture real world complexity, we introduced the deep neural network. The deep neural network takes those exact same user and item embeddings we just created and feeds them through multiple layers of nonlinear logic. This allows the model to learn complex nonlinear relationships, connections that no simple linear equation could ever find. The result is a far more accurate, personalized prediction, giving us the final edge in recommending the perfect anime.
Assalamu alaikum wa rahmatullahi wa barakatuh. So I'll quickly explain the code inside the recommend anime.ipynb file and how our final hybrid system works. The notebook starts by loading the two trained models, the content-based filtering model and the item-based collaborative filtering model. The CBF model uses anime genre descriptions and metadata to find similar shows, while the CF model uses user rating patterns. Our collaborative filtering method uses adjusters cosine similarity, which is better than the normal cosine because it removes user rating bias. This makes similarity between items more accurate. After loading everything, the notebook defines the hybrid recommendation function. This function takes the score from both models, normalizes them, and then combines them to produce a final ranked list. The idea is to get the strengths of both CBF helps with the goal start and content similarity, and CF gives rating based accuracy. For the test run, we simply provide a user ID or an anime title. The function then fetches the top recommendations from both models and merges them. The final output shows the recommended anime titles with their combined scores. So overall, this notebook is where everything comes together. The models are loaded, the hybrid logic runs, and we generate the final recommended list. And that's all from my side. Thank you.
Overall, the hybrid method worked great. It beats the individual models in accuracy, and more importantly, it gives more diverse recommendations, so users don't get stuck watching the same type of anime forever. The system is strong, but we can definitely push it further. Upgrading the DNN's embedding layers could help capture deeper relationships between users and anime. And adding temporal data, like the order someone watches shows, could make the system even better at predicting what they'll want next.